Welcome back to ShotokuTech. In the leap year edition of ShotokuTech News of the Week, I reported that the Smithsonian has opened up 2.8 million images to the public. What I didn't realize is that some of those Smithsonian artifacts are available in Tinkercad. Let's check it out. Okay, so Tinkercad is free, and you can use it even if you don't have a 3D printer. You can try your hand at 3D design, and it's fun. But let's go see what the Smithsonian artifacts look like. You go to Basic Shapes over here, and we're going to select Smithsonian. Oh, cool, they got a Bell X1 plane. We got the command module from the Apollo 11 mission. Takes a minute for that to pop in. We got a woolly mammoth. Oh, that's spooky. We got a triceratops head. There's a boot, a flower, a ritual incense burner, a wine container, a chair, a motor, Morse telegraph, telegraph relay, Rutherford B. Hayes bust, Lincoln's hands, Lincoln's face, Helen Keller, Anne Sullivan, and a bust of George Washington, and a whale fossil. So there's only 20 of these things here. Kind of disappointed in that, but I'm not going to complain much. I'm going to go ahead and export out this Triceratops because we're going to print it, because I think that'll be cool. So we're getting it ready to download. Okay, so it's just under a generic name here. And we're going to take that and bring it into Curio. Alright, let's take a quick look at the Curio Settings. I've already selected Ender 3 PLA on a 4mm nozzle. I'm going to go with the 0.2mm layer height, so that's 0.2 of a millimeter on each layer. The line width of 0.44 with an initial line width of 0.74. So we're going to use a 2-wall line count, meaning there's going to be 2 outside walls, and there's going to be 4 top and 4 bottom layers. I want to make it pretty sturdy, so I'm going to use 30% infill. These temps are working fine for this inland blacked PLA that I have on the printer right now. This retraction and retraction speed kind of help cut back on the stringing. That's basically pulling the material back while the print head moves when it's not printing, so it's not drooling plastic. I'm going to slow it down, go with 30 millimeters per second. That'll hopefully improve the quality of the print. We're going to enable print quality. Now I've skipped over support here on the build plate adhesion because there's very little material actually touching the build plate. We're going to go ahead and use a brim. But I've also gone down under experimental, clicked this gear, and I've made tree support visible so you can use tree support. And tree support's really much better in most cases than the regular support. Let's go ahead and slice it. Okay, and I'm going to save the file. I'm going to go ahead and rename it to Triceratops. There we go. And then we come back here. I've actually already sent it over to the printer, so it's underway. We can take a look. So basically you upload that file to Octoprint. Click on the print button. There's some other settings you can apply in between, and you can modify the temperature if you wish. But we'll come back to that. So like I said, I was just a little bit disappointed there wasn't more of these cool objects on Tinkercad. So I'm going to click on this link and see what's up. Okay, here's the story. They basically show you all the objects for the most part that are available there. But I'm going to click on this URL, and this takes you to the Smithsonian Open Access Initiative. Wow, search for open access images and 3D models. Let's see, 3D Voyager. I'm going to click there. Oh, this looks cool. Looks like there's 2,200 3D scanned objects here. So let's take a look at this blue crab. Now this is a really cool interface. You can use your mouse. I'm going to go ahead and go full screen on this crab. So if I use the scroll wheel on my mouse, lets me zoom in and out on the crab. Now the left mouse button lets me turn the crab. Oh, I'm looking at the crab's butt. Oh, the face isn't that much better. And then the right mouse click lets you move the object to around the screen. So you can scroll in, scroll out, rotate, or move it all about. Okay, I'm going to hit escape to come out of there, but there's probably 2,200 objects that some of those you might be interested in looking at yourself. So you can choose objects based on which museum they're from, the media type, the visual material. Those don't really have anything of any value there. Place, you can choose by region. Topic, the topics does seem pretty narrow. It doesn't seem like there's that many of them, so you might get stuck doing some searching, which you certainly can do. Up here you can search at the search bar. Let's check something else out. I think you're gonna like it. Let's see, command module, Apollo 11. I'm gonna let this load up. Now again, these are 3D scans, meaning somebody's scanned the original object with a 3D scanner to create this view. Now here, the scroll button doesn't let me zoom in or out, and the right mouse click doesn't let me move the object on the screen. But using the left mouse button, I can pan all around the interior of the Apollo spacecraft here. This is incredible. Wow, just what incredible detail. If I look out the door, I see scary space monsters. No, I'm going to look back in here. It's a lot better. Okay, I'm going to hit escape to go out of there. So I really think that you all will enjoy checking out the Smithsonian 3D digitization project. And like I say, all of this is free and available for you to explore. Tinkercad, again, even if you don't have a 3D printer, you can try your hand at 3D design and check out some of these objects that were added from the Smithsonian. Let's take a look at that Triceratops head. Watch it print. And let's check out the finished product. Wow, that's cool. Okay, thank you very much. Thank you for watching ShotokuTech. Please subscribe, comment, like, and share.